Uh, Good morning, everyone. It's a pleasure to be here with you all at the Uttar Pradesh Power BI Club Series. Today, I will be I will be giving a session regarding decoupling compute and storage. I'm Avinash Timaredi. I graduated from Osmania University in 2009 and have over 15 years of experience in software engineering with the primary focus on data engineering. I started with ETL tools, then transitioned to Hadoop ecosystem, where I specialized in migrating projects from traditional ETL to Hadoop. And for the past 5 years, I have been deeply involved in cloud technologies, leading both migration from Hadoop to AWS and also developing cloud native data engineering solutions. Like from scratch, we developed some tools and some pipelines in mostly AWS and other like few Azure and GCP public cloud services as well. Today, I'm excited to share insights on how cloud computing and decoupling architectures are transforming the way we build intelligent, scalable data platforms. Before we dive in, let me give you a quick overview of today's agenda. Like today, in the presentation, we will start with traditional monolithic applications, their limitations, and next we will look at introduction to cloud computing and discuss why it has become such a game changer for data platforms and how cloud computing has enabled a shift to modular or decoupled or like microservice architecture. We'll explore the key advantage of decoupling, supported by real-world industry examples. We will discuss different cloud deployment options as well. And finally, I will share an implementation roadmap. That is, if you are planning to move from on-prem to cloud, what are the steps we need to follow? What are the common challenges? And at the very end, we will look into future trends in intelligent data systems. Okay, now let's begin with the first slide. And so here, like in this slide, we'll discuss about what is a monolithic application. A monolithic application is a single unified software system where all components, such as user interface, business logic, by business logic, I mean like transformation and everything, you want to apply on the data, and then the data access. Right, by data access, I mean the tables are like the S3 files, which will be written at the end of the transformation. All these three are tightly integrated and run as one unit. Why were most software projects designed this way, like using monolithic architecture? So it starts with simplicity. It is very easy to develop an application as a monolithic application. Assume like you have a huge application, and if you are making a small change, if it is monolithic application, you can test the code using some test cases and test it within your local without deploying even to the actual server or like actually deploying it. So it makes coding and testing very easy. Even the integration testing will be very easy if the entire like if we are developing it as a single module instead of microservices. That's the reason, like simplicity is what helps, like is why we choose monolithic application. And, and then tooling, early development tools and platforms such as Java, EE, .NET were optimized for monolithic design. And then performance. Direct communication between components can be faster and simpler because like everything is coded within a single module. And then like team structure. Smaller teams could manage the entire application lifecycle. So these are the main criteria why we like initially it was true like most of the people followed monolithic application. And why did monolithic applications became prominent? In the early days of software engineering, hardware and network limitations made distributed system complex and costly. Like it was very hard to separate, have a microservice architecture because of the networking limitations. Monolithic design allowed organizations to quickly build and deploy. The easy to build and fastest, and it is very easy to deploy to prod or like higher environments, made monolithic design like used by everybody. So these are the reasons like why initially monolithic application was like so prominent. So what are the limitations of monolithic application? Why we had to move out of monolithic application and search for newer ways of software designing? Monolithic applications, while simple to build and deploy, present several challenges as system and business needs grow. The first one is scalability constraint. Since storage and processing are tightly coupled, if you want to increase processing, you also require to scale storage. So, for example, let's take you are working for an organization where they have like complex transformations. You have to join sources or like data sets from like various tables or various files, and you are providing at the end like you are just doing one simple present report. So here the transformation, the processing is huge, but the end result is like a simple file. So like in the monolithic architecture, if you want to increase process like alone, it's not easy. Like you have to add like entire uh, vertical scaling is not always easy. Like you have to add like entire like both processing and storage. That is horizontal scaling, and it is very it's not easy. It's like it's very costly as well. So first limitation of monolithic application is scaling. If you have to scale both the processing and as well the storage together. And next is technology locking. All components are tightly integrated, like making it hard to adapt any technology. Like assume like you are on a Oracle database and you wanted to move to a Snowflake data, not Snowflake, but a DB2 database. Like the migration has like takes a lot of effort. So and assume like if there is any new database like that's in the market and like it it aptly suits your business use case, you want to migrate, it is not easy. Like the migration, like you need to redesign your tables, then migrate the data. Like as the monolithic application requires all the data to be in the place where the software for the database resides. So there is like it's not easy to adapt a new technology in the market. So that's also one limitation. And then the main reason is capital intensive investment model. So how monolithic application works? Like if you are planning to develop a huge application, then you have to buy the necessary hardware to it. So how you decide like what needs to be like how much the capacity needs to be. You design it for peak capacity. That is like you are assuming like during peak hours you need this much of processing. So you buy for that, and the rest of the time you are not using your hardware like to its maximum capacity. So your capital investment, like when not even you have not even started like working doing it to prod, like you need to buy all that equipment, and then you need to code it and push it to prod, deploy it. So even when your application is not yet deployed and nobody is using that, you have to do a lot of investment. And the investment you are doing it is for peak. You are assuming like this many people will be using this, and so there is a lot of capital involved even before like people started using it. And So that's the main reason, like main drawback of monolithic application. And then complex provisioning and maintenance, like you need to have like a separate team to maintain the hardware, then upgrades, then like if need more capacity, like a lot of work used to be happening in the backend. So that's also one disadvantage. And slower innovation, like as I mentioned in technology locking, if you want to adapt a new technology, it's not easy. So your innovation also slows down because of that. Okay. So these are the limitations of monolithic application. And then like introduction to cloud computing. So what is cloud computing? Cloud computing is the delivery of computing services such as servers, storage, database, networking, software over the internet. Okay, it's like they are providing you like databases and storage over the internet. Like you don't have to own those resources. How did cloud computing start? The concept emerged in the late 1990s and early 2000s, building on earlier ideas of distributed computing and virtualization, especially software as a service. And then Amazon Web Services launched in 2006, offering storage, that is S3, and compute services, EC2, to the public, marking a major milestone. Then other major providers like Microsoft Azure, GCP soon followed. Why could cloud computing become a prominent? First reason is scalability. Instantly scale resources up or down based on the demand. Like you can increase your resources like instantly. It doesn't take like more than like few seconds. Best case scenario, and like sometimes few minutes. And if you think like during these hours you have like a lot of processing, then you can increase the EC2 or like the processing part. And then after the peak hours, you can reduce it. So that's scalability. That's one of the main reason. And next one is cost efficiency. So you don't have to invest like even before you start coding it. You don't have to invest, need to buy all the hardware required. So you can start working on the code and then like designing or developing your application. Once it is ready, or like once you test it in your local, you can then deploy it to AWS. Like during that time, you can then like you can actually start deploying your resources, like buying those resources or services from cloud providers. So it's very cost efficient. And then like the scalability. Why cloud computing was not possible until the 2000s? As I mentioned, like AWS started around 2006. So why was it? Like why didn't we find it sooner? So the first reason is like limited internet bandwidth and reliability. Before the 2000s, internet connection was slow, expensive, and unreliable for large-scale data transfer. High-speed broadband was not widely available, making remote access to computing resources impractical. Then lack of virtualization technology. So early servers ran on like single operating systems and applications with no efficient way to share resources. Like by virtualization, what I mean is the ability to run multiple virtual machines on one physical layer. Like for example, like take Amazon EC2. So they provide like they have one huge server like where they give like instances of that server to who are requesting for EC2. Like it requires like virtualization, and so that like we couldn't run multiple separate processes within a huge server. Okay, and then expensive and inflexible hardware. Computing hardware was costly and not easily scalable. Data centers were designed to fixed workloads with little automation or dynamic resource allocation. Like the hardware was like used to be very, very expensive, and they were not they do not support like automatic or dynamic resource allocation. No on-demand service model. Like softwares and infrastructures were sold as a product, not as a service. So that's also one reason. Like if you have to have like some software like a database like Oracle, you need to buy buy the product as well. Like you can't use it as a service. And the concept of like pay as you go or renting computing resources didn't exist. Like no, since of these limitations, like the pay as you go was never had a lot of demand. Then security and trust concerns. This is also like one of the major reason like why people didn't go to wanted to have cloud computing. Like organizations are hesitant to store data outside the promise, like outside their premises due to security and privacy concerns. Cloud providers had to develop robust security, compliance, and reliability standards to overcome the security and trust concerns. Okay, so once cloud computing became prominent, people started moving from monolithic architecture to modular. Like cloud computing has revolutionized software architecture by making it practical to move from tightly integrated monolithic system to modular decoupling designs. This helped organizations to build applications as collections of independent, scalable components, like microservices, each responsible for a specific function. Okay, the architectural shift. The move from tightly integrated single unit application to modular system where compute and storage are separated can be managed independently. Like this kind of like think shift in architecture was happening is the main reason why like monolith like we moved from monolithic to modular or like microservices and enabled by cloud platform. As I mentioned, like cloud platform played a huge role in this architectural shift. And then like benefits of modularity as well, like as I mentioned, like uh, the scalability constraints were solved because of the cloud, and adapt to new technologies was faster, improved fault isolation and improved resiliency as well. So you can have like as many backups as you want, like, and you can change it like whenever you want. So the resiliency, all these were provided by cloud, and that's also one of the benefit. And foundation for modern data platform, like modular architectures are the backbone of cloud native solutions, supporting microservices, serverless computing, and like real-time analytics. So all these factors help us to shift from monolithic to modular. Yeah, and we will going through like all the limitations we discussed in monolithic architecture, like one by one, and how the cloud and modular architecture is solving those. The first one is the independent scale. So it is one of the most transformative benefits of cloud native architecture. And like it is the ability to scale, compute, and storage independently, unlike monolithic systems, where resource must be scaled together. For example, like take a data engineering application where you have like processing and then storing, and assume like you had to do a huge processing only certain days of a week or a month. You can increase your processing services like EC2 or Lambda, like whatever is required, only during those peak hours. Like the scalability, you don't have any constraint on scalability. Like you can increase only processing or you can increase only storage, like however you want. That flexibility, okay, is provided by cloud. And no more resource imbalance. Like what it means is like before you had to have both processing and the storage, like both grew like hand in hand. Like if you want to have more processing, you also need to have like more storage. They you have to increase together. So now that cost like resource imbalance. Like you're paying or buying unnecessary storage even though you didn't want to. This is also solved because of the independent scaling. And Elasticity is like instant scale up and down. It's like so you can this also is supported by cloud computing. And the other problem cloud computing solving is cost efficiency. Like as we discussed, cloud computing fundamentally changes the financial model for IT infrastructure by shifting from large upfront capital investment. Before cloud computing, all organizations, like small or big, they had to pay upfront capital. They have to do upfront capital investments. But with the advent of cloud, it has changed to pay-as-you-go approach. Organizations now can better align cost with usage. Like now they only have to allocate like the budget based on the usage. It reduced waste and achieved like significant savings. Okay, and yeah, so these are all the points like I discussed. Then innovation at speed. So this was one of the limitation of monolithic. So now cloud platforms empower teams to innovate faster than ever before, like with instant access to scalable resources, cutting-edge tools, and managed services. Organizations can rapidly experiment, develop, and deploy new solutions. It was very easy. Like if you have like any new solution to a problem and you needed like more resources, like you can easily request those resources and deploy it. So it made innovation much faster. If you want to do some POCs, that's also became much faster. So with the cloud, like the development cycles became much faster, and even the deployment, like so you didn't have to plan for deployment. Like if you wanted like new server or like new storage, it was very easy like to increase the up like the processing or like storage capacity. It was very easy. Like you didn't have to plan, you didn't need like much approvals. It was like much faster. And the last point is access to latest technologies. Like assume like there is a new service like that can improve your performance or can solve your business use case. You can easily pay for the service, and assume like you have a new database and you wanted to use that. So you can just pay for the service and give the service access to your files, like it may be S3, and then you can start using that. It's as easy as it gets. So this all these factors improved innovation. So next step is like simplified provisioning and maintenance. Provisioning and maintenance infrastructure in traditional environment is often complex and time consuming. Cloud services simplified these processes through automation, like managed platform and self-service capabilities, enabling teams to focus more on innovation and less on routine operations. So, like a cloud provide architect serverless services, like you don't have to do any provisioning there, and they also provide where like uh, they also provide like services where you can plan your capacity. Like if you think like the application processing percentage reach like 80%, then you can keep on adding processing. Like so they provide like serverless, and they provide managed services. So which helps your engineers to focus on actual work instead of worrying about the resources. So this is also one of the main advantage of public, I mean the cloud. Okay. So like since till now we discussed like what's a monolithic application, what's a cloud, how the cloud is solving all the limitations faced in monolithic application, and also how cloud helped you to shift your architecture from monolithic to microservices. Now we'll discuss more about like what are all the deployment options cloud provide. Okay, the first one is a public cloud. So by public cloud, like these are the services delivered over the internet by third-party providers and shared among multiple organizations. So major providers of public cloud are like AWS, Amazon Web Service, Microsoft Azure, GCP, IBM Cloud, Oracle Cloud. Like so, these are all like public cloud. And then comes the private cloud. So what private cloud means is like this cloud infrastructure is operated solely for one organization. Like assume like a big finance organization like JPMC, BofA, like Citi. They have their own private clouds. So it is not shared with any of other with any other organizations, and they mainly own provisioning and all those things. So how it helps these organizations is like mostly the data security, and it also reduces individual teams maintenance, because like assume like a company has like 100 teams which are working on different like services, like they wanted different storage and different processing. So each team like need to have like few people who had to manage those resources. Instead of that, these companies built one private cloud like where everything can connect to them. So it became like very easier, like for only few people are required to manage the private cloud, and rest of them can focus on their work instead of the maintenance and deployment activities. So private cloud is also like very huge, like almost like all the finance organizations have their own private cloud. And then comes the and like private clouds are like, I mean, like companies, these organizations don't have to start the wheel from zero. Like there are already private cloud providers like VMware, OpenStack, IBM private cloud. Like these companies help them to set up the private cloud. Then the hybrid cloud. Hybrid cloud is nothing but a combination of public cloud and private cloud. Like almost like any finance sectors have their applications in both public and private. It's just the combination of that. And the final one is community cloud. Community cloud is a shared infrastructure for specific community. Like assume like healthcare services, like Blue Cross Blue Shield, like which spans over multiple states. They have like this concept of community cloud, like where they share all the resources between the BCBS, because all of them have same security related rules, and so like and the same policies they follow. So they share, like they have a community cloud instead of one state paying for this. Like now it's divided into multiple states. Okay. And oh, sorry. And like there is one more strategy, like multi-cloud strategy. So what does it mean is like within public cloud or like within private, let's go with public cloud, we have multiple providers. By multiple providers, we have AWS, GCP, and Azure, and so on. So instead of only using services from one particular provider, now what companies are doing or organizations are doing is like they are trying to explore all the services from different providers. So this why they are doing is like this helps them not to be dependent on one vendor. Like so, what it means is like decoupled architecture. I mean, reduce single vendor risk. Like assume like if any provider any provider rules or like policies that they change later on and you are not happy with them and you want to move to a different provider, the switch can be easy, faster if you are already have your like hands on these, like if you are already working on these multiple providers. So that's the reason like many of the organizations have multi-cloud strategy, that they just don't deploy everything on one provider. And like 72% of enterprises are of multi-cloud. Yeah, and one more advantage of multi-cloud is resiliency. Like by resiliency, I mean like it's not a regular use case, but assume like something happened and one of the provider was not able to provide one of their service, then you can switch it to another provider and use the service. So that's what resiliency means. Multi-cloud strategy provides this as well. And yeah, one good example of decoupling in action using a multi-cloud approach. So if you assume like you have a simple application where you need to do some processing, then some streamline some pipelines, and then like storage. So this example is using multi-cloud. So here for compute, we are using AWS Lambda. For the pipelines, that is for data engineering, they're using GCP, Cloud Data Flow. And then for storage, they're using Azure Blob Storage. This is not a very, I mean, like you don't see this kind of use case like very often. Because like integrating between different providers like requires additional work. Like you need to have additional APIs and something. And this is not how like people do multi-cloud. Like by multi-cloud, how they do is, oh, you have an entire application in one provider, and then like if another team is working on another application, like they will have them in the another provider. So like you will try to have like as much as possible like one application in one provider. You will switch, like you will split the application between multiple providers only if it is needed. So what I mean is like this is a very basic example. Like we do not do this like that often. To like multi-cloud to follow multi-cloud, it depends on the how the application is designed. Okay. And concrete and easy to understand example of decoupling is data lakes and lakehouse. Data lakes were implemented like before cloud, but it was harder to implement, scale, and manage. But after that, after the advent of cloud computing, it became very easy to implement data lakes. So, so why people started using data lakes and is like it reduces data silos by 62%. Like what data silos mean is like assume like you're working on a huge organization, like there are like 100 different teams. Each team wanted their own data storage and like database. So each team creates their own database, and these are called like data silos, like as they are like separated from other data within your organization. So like there is one issue with data silos is like you do not have single source of truth. Like assume like one database says like this person has this many, has bought this many, or like is living in this address, and the other database says like this person is living in another address. So there is a contradiction there, and to avoid that, instead of having so many data silos, like you will have entire thing dumped in data lakes. Okay, and then whichever team wants that, however they want to process it, they pull that from that data lake and process it. So this is like unified, like it provides accessible access for any business like AI or ML. Okay, and also time to insight shortened by 53%, like data lakes. As I mentioned, like you dump everything into the data lake, and then you whatever you want to have, like it's available there. Like you don't have to connect multiple tables, or like you don't have to connect to different databases, and so it reduces the time. And yeah, data lakes use like cloud a lot. I mean, after cloud, data lakes, creating data lakes became very easy. For example, take a use case like where you have like structured, semi-structured data, like everything you can dump into S3, AWS S3, and then on top of these files, you just have to create a table, which is easily doable with Athena or AWS Athena, AWS Glue. That's it. You have your data lake ready. All you need to do is like to which user, what role, what tables you need to assign. So only the policies and roles. That is somewhat like complicated process. Other than that, like you have your tables ready. All you need to do is like based on your use case, you need to join them and transform them and create reports. Like data lakes are like became a huge hit after cloud. And one more good example of cloud is decoupling and cloud is Microsoft Fabric. It's a real world example of decoupling. It is a suite of data and analytic tools such as data engineering, data integration, data science, real-time analytics. All of these provided like under a single umbrella called Microsoft Fabric. All of these are available in Azure. Okay, so okay. Now, like I was mentioning, like cloud helped a lot to organizations, right? Like we also, so there are also some organizations which do this analysis, like how they help. And one among them is Flexera 2020, like Flexera, and their 2025 cloud report says that Azure adopters save up to 38% in cost. Like whoever migrated from on-prem to cloud, it helped those businesses to save up to 38% in cost. Okay, and Netflix accelerated innovation and scalability. Like by moving from monolithic Hadoop cluster to modular cloud-based data lake on AWS, Netflix enabled rapid scaling, faster analytics, and more resilient data pipelines. And the other is the cost optimization, performance, innovation, are like so. On monolithic, you had to think if you want to have like good performance, you have to have more resources, which is not cost not optimizing the cost. Okay, but with the cloud, both cost optimization, performance can be done together. They are no longer like trade-offs. Okay, you need to choose one. Okay, and in the previous slide, we discussed how cloud is impacting software applications or software engineering. It is also playing major role in analytics and AI acceleration. Okay, McKinsey, Deloitte, Gartner data, like leading research firms highlight the transformative impact of decoupled architectures on like analytics. ML deployment cycles cut by 72%, like on cloud. So it's an easy example for that is like take the data lake example in the previous slide. So like the data engineering team is dumping everything into data lake, and an ML team wants to use that data. All they need to do is get access to the table, then get access to the uh, uh, notebooks. Like clouds also offer something called notebooks, like Spark notebooks, Jupyter notebooks. So you get access to that, and you can write all your model. You can run all your entire code in that and do the apply the modeling on the data, and you can see the results like very easily. Like the development process is very easy. So the cloud also help like ML development, and the real-time analytics agility boosted 80%. AI adoption success improved like 40%. Like since the time reduced like a lot to test your models, the engineers had like more time to do multiple layers of testing, and it improved the model performance as well. In previous slide, like we discussed how cloud is helping AI. And in this slide, like we discussed like AI, how AI is helping cloud. So AML tools auto-tune workloads and cost. Like so, if you deploy a train AML tool to to like to automatically provision and or remove the services like instances of an EC2 or like something, they get trained on that, and they know like when the peak performance is required, when the performance will slow down. Based on that, they increase or reduce the resources. So it helps the organizations that are using, like it's a cost benefit. And then like predictive scaling for seasonal spikes is the same thing like what I mentioned. And then intelligent caching and tiling. So even if you take S3, right, like they have a tiling called intelligent tiling, intelligent S3. So like S3 has multiple tirings. So like based on how frequently you access data. So the intelligent tiling option, when you choose that, it sees like if a file is not being accessed for so long, it moves into a different tier where it saves cost to the company. So even like cloud, AI in cloud like is helping a lot to improve more like cost savings and performance. So implementation roadmap, what I want to discuss in this slide is like if you have decided like to move from on-prem to cloud, what are the steps you need to think? So the first one is like assess current infra. Begin by evaluating existing infrastructure and identify dependency. Like you need to have a good understanding of existing architecture. Then pilot workloads. Like do not start immediately migrating from like redesigning the existing architecture. Like start a pilot project on cloud to get a better understanding of is the microservices architecture using the cloud will actually solve your business needs. So start with the pilot workload, then adopt manage cloud native services. Like there are like some suit like of instead of going through, like if you want to have a data storage, like or like if you want to build an analytical process, instead of going through each and every service and you deploying that, some providers provide you a suite of applications together. So, like for example, Microsoft Fabric, as I mentioned, like it's a combination of multiple Azure tools. So it eases your process. Like you don't need to do the integration; it is done like easily. So try adapting like managed cloud native service, and then expand to enterprise scale multi-cloud governance. So scale up and implement governance for multi-cloud environment. Like as one of the main concerns with the cloud is like privacy concerns. Like you need to scale up the governance. So like even though like cloud is solving many of the limitations in monolithic, there are challenges as well in cloud, and we will discuss them in this slide. Okay. The first challenge is like complexity in orchestration and mitigation of automatic and fabric things. So, for example, assume we're using multi-cloud approach, then orchestration is going to be very complex. Like you need to start the services in different cloud, and there is no easy integration between the services. So, like orchestrating is going to be a challenge. And not only that, like even file lineage or like tracking jobs, monitoring and troubleshooting, all of these are going to be a challenge. You need to keep in mind, like when you are designing your like architecture. Then the other challenge is like data governance. Like since data will be stored in different places, you need to have a good tracking of that. So you can go with centralized cataloging and in lineage tracking to improve governance. Okay. And the last one is cost predictability. Like even though cloud reduces cost, like you have to be very what do you call, like you need to design the applications like properly. If you're not monitoring, like sometimes if you're like using like unnecessarily some of the services, like the cost might increase. Like it's a very like it happened to a lot of the organizations or teams. You should have a good monitoring on like on the cost, like how much you should have some alarms, like if any job is running for a long time, or like if you're exceeding some budget. So monitoring and AI-driven tools, like the providers also provide like monitoring and AI-driven tools to help manage and predict costs. So the cost predictability is not such a big deal, but you should be wary of that. Yeah, like as we discussed in previously, like what are the limitations of cloud computing? First one is unpredictable cost. Even though like the providers are providing like all the necessary tools to monitor the cost, but we should always be wary of like cost. For example, like ideal virtual machines, over provisioning storage or frequent data transfers can quickly inflate bills. Then network latency and performance. So assume like you have your storage in one location and you are processing in another region or availability zone. So there will be a delay in it because of the transfer. So you also need to be wary of that. Then complexity in the architecture and management. Design, monitoring, and optimizing decoupled cloud architecture requires new skills and tools, like increasing operational complexity. So, and the final one is the security and compliance challenges. Managing data across multi-cloud services and regions can complicate compliance and increase the risk of misconfiguration. Now, you need to be like very careful on providing access to your resources. Storage side. Okay. Well, one solution to in previous slide we discussed network latency and performance. Right? Like one solution to that is like storage side computing. So moving your computing and storage to a single region, it minimizes data movement and enables embedded ML analytics at storage layer. Machine learning analytics can be performed directly where the data is stored. Is like that's what it means. And the future of intelligence system, so cloud providers are trying to adapt AI as much as possible in their services, and with that, they are trying to do self-healing, self-optimizing infra. Okay, native AI orchestration at scale. So as I mentioned, file tracking and monitoring the jobs is becoming difficult because of the microservices. So cloud providers are coming up with a native AI architecture which can does that easily, and then full convergence of analytic AI and transactional workloads. So there are also all type of workloads will run together like seamlessly on unified platforms. So they're also coming up with this. So like the key takeaways, like what decoupling is, it's just like what are the advantages of decoupling, like cost efficiency, agility, and innovation becomes much easier. There are like proven impacts of this, like saving cost by 38%, analytics agility is becoming like improved by 80%, ML development and deployment is becoming 72% faster, and like enabler Microsoft Fabric as a central enabler for unified cloud native ecosystem. So like Microsoft Fabric is also trying to bring up multiple services together to reduce the development time. Okay. Uh, Please let me know if anyone has like any questions. Hey, hi Naila. Like I'm done with the presentation.
Hello, yes. I have collected those questions. I'm dropping them all in chat. You can cover them in the live itself.
Okay. Uh, so data governance and compliance, like when using a multi-cloud, do I need to type it in or like do I need to answer them? Naila.
Just
So
explain them in the live itself.
okay. Um, so like the first question is like, how do you handle data governance and compliance when using multi-cloud strategy with decoupled architecture? So it's like as simple as like when you are doing it using a single provider, you apply all the data governance and compliance to a single provider. Like now, since we have multi-cloud, like you have to follow the compliance and the governance for each provider. Assume like you have a data in AWS and like you are doing some transformation and doing it and loading it in GCP as well. So you need to apply same rules like in both the both the places. So assume like you have one table in AWS, like you will have some security groups on top of the table, and when whoever wants to access the table, they need to request for those security groups. So you will know like who is requesting that, and you based on the use case, like you will approve that. Same approach you need to follow in GCP as well. So so the answer is like data governance and compliance. Like it's easy. All you need to do is like you need to instead of like you having one like assuming like you having one provider, you have to do it in multiple places. Like the process will be same, only these steps will differ. Okay, and second one is what are the first steps of migrating a legacy monolithic ETL system to cloud native decoupled platform? Okay, so like as I mentioned in the slides, like you need to first have a proper understanding of your application. Assume like you are trying to migrate, as you asked, like for ETL, right? Assume like you have a data warehouse in Oracle, and then you're using ETL tool like Abnishu, Informatica, like whatever. Like you have your DB like Oracle in the server, and then you have your ETL engine on the server. You are getting files using MFT. Okay. this is your simple use case. Like MFT is placing files from some other server into your server, then ETL is processing that and loading into tables. So this is your it's a simple data pipeline. Now what you need to do is like the first step is to understand the architecture, like have a good understanding of the transformation and what are the tables, columns, like where, how are they being used, and then like you can deploy. Like then the second step, you can, instead of writing the files in your on-prem, you can change it to S3. Find out if your ETL supports writing to S3. Then like you can switch S3, and then if the ETL itself can be is provided in the cloud, you need to find that, and then like you can slowly switch the ETL application itself to cloud. So yeah. And the third question is, can you explain how AI-driven cost optimization tools actually work in practice to avoid unexpected load? One good example for this is like S3. S3 has multi-tier, like different tiering approach. I don't remember the exact names, but so the first option is like you want the files whenever like easily accessible. It's very costly, and there is one tier called infrequent access, which reduces the cost like almost like 90%. So by choosing the intelligent tiering option, assume like you have a file that's not been used for like for over a period of 20-30 days. It automatically pushes the file into intelligent tier. Sorry, the infrequent access tier. So it saves your cost there. And that's only one use case. Like you can also adapt them in processing as well, where like it improves the capacity based on the peak performance. Like if you are having an application and it only uses peak performance on the business dates of like beginning of the month, that is like we call it like BD1, BD2. So for first 5 days, if you want to have more performance, the AI can predict that and increase the performance during those 5 days, and after that it can reduce the capacity. I mean, this is in this example, you don't need the help of AI because of it's happening over a period of days. But this AI can do that within a span of like seconds or minutes, which can save you cost. And the final question is, what are the most common pitfalls when implementing storage-side computing, and how they can be avoided? Yeah. So I mean, like one main reason, reason why storage-side computing may not be feasible is resiliency. So assume like you have everything in US East 1, it's a region in AWS, uh, and like for some reason it won't be happen, it won't happen, but the chance of happening it is like 99.99%. But for some reason, AWS US East 1 region goes down. Since you have your compute and storage, you will not be able to access them. So what organizations or teams do is multi-region approach. They follow multi-region approach, like have a backup of like have all the files in US East 1 and then have a backup of these files in US West 2. And like whenever this region goes down, like they will switch it to US West 2. But in order to do that, like you need to be like constantly testing that. So this is what we call like switching the region. So like then you switch like to know whether the multi-region approach is working or not. Like assume like you switch it over to US West 2 like once in a while. So then there will be a latency. So, I mean, like having storage computing helps you process the time. I mean, helps you improve the performance, but you have to have a multi-region approach as well, like multi-region solution as well, to improve the resiliency. Nela, I'm done with my questions.
Okay, thank you so much for joining us and sharing your insights with us. It was really an insightful session.
I'm
So
sorry, can you?
before ending the session, I would just like to ask you if you want to share one piece of advice apart from this domain stuff to our members or a community, it would be really nice from your end.
Advice related to data engineers, like to the people or to the staff, like whom like whom should I advise? And like it's to the engineers like who are listening, like
Yeah,
who are
mainly students.
okay. I mean, it's becoming very difficult, not only to the students, like even to the existing software engineers, like what to learn, like as the AI is changing like very fast. Like a few months back, some people wanted to start some ML model training. Now, like people, like it's changing to Gen AI, then it's changing to vibe coding. Like things are changing so fast, like people often lose track on what to learn. My advice would be learn like a good programming language, even though LLM suits provide the code instantly. It would be good you, for you to have a skill to be able to understand the code easily and then able to be debug them. Because like LLM are good, they are able to provide code, but in an organization, like you will have like a lot of code, like thousands of lines of code, and you should be able to figure out, you should be able to provide inputs to the LLM, like which code needs to be changed, what needs to be changed. Okay. So my suggestion is like coding, giving good hands-on coding. That is always useful. Um, Anything else now?
No, thank you so much for joining us once again. I'm ending the live session now, and if someone wants to connect, they can connect with you on
Yeah,
LinkedIn.
yeah, correct. I have my LinkedIn lecture. They can message me. Yeah. Okay, Nella,
So
then
I
let's
have
see you.
disconnected.